Hello. In our second video lesson this week, we're going to focus in on one more case to prove congruency. Okay, this one works a little bit different than the other two with included angles. It doesn't have to have an included part, but it's still really a form of angle side angle. So let's kind of take a look at that and practice a little bit more with proofs. Again, focus in on how proofs are being written in a logical order. Kind of try to understand that pattern so then when you go to start writing these on your own, you're able to complete that. All right. So in our set of notes here for lesson 4.4 and 4.5, we're going to focus in on one more case for congruency. Let me make this a little bit bigger. Okay, we've got AAA, which stands for angle, angle, side. Okay, when you have it marked on the triangles itself. Now keep in mind that you have to have one set of sides that you know are congruent, and then you have to have two sets of congruent angles. The side is just not located in between, but I want you to kind of just take a look at this and see what it means. So in this scenario, we have angle A congruent with angle D, and we have vertical angles right here. So then you would probably be marking in the angles at B. And then we had a given set of sides that are congruent. If I was working my way around this triangle, we should notice that we go from an angle to a side. Okay, it's in that order. Or we can see that that side is not included between the two angles. It's outside that, so we write it in that order outside of that. If this is true, okay, once two angles of a triangle are congruent, you could make that third angle congruent by your third angles theorem. And then it would be a form of angle side angle. So I always look at angle, angle, side as a form of angle side angle. But we use this case to kind of shorten up our proof, okay, or the steps within our proof in that scenario. So always look carefully, though, when you're looking at your proof problems, okay, which case are you actually proving? Because you're providing the evidence and then stating the case. So you do always need to match that up correctly. But if we know we have our angle, angle, side scenario, we should be able to write our congruency statement. Now in this one, I started that first triangle as triangle ABE. So again, make sure to match up those corresponding angles when you write your congruency statement. So angle A corresponds with angle D, so that has to be my first letter. Okay, B with B, and then E with C. Okay, so that would finish that up. Okay, HL, which is hypotenuse leg, is another congruency case. Only works with right triangles because you can't have a hypotenuse without a right triangle. So that's another scenario. We're just not going to include that this year with our assignments or our proofs. So you don't necessarily need to worry about it, but it is another scenario that does end up working. Okay, so the only one we're actually adding in this lesson will be angle, angle, side. Okay, so let's look at some examples and what that would look like or how that would work. Okay, so here, what we want to do now is prove our triangles congruent with a certain case. So if we were going to use that new one, angle, angle, side, what would have to be that third congruency statement so that I could make that case in that proof? Okay, we'll always take given information and mark it on your diagram. So we have GH congruent to MN. Okay, and we have angle G congruent with angle M. Now, if we want to be using the case angle, angle, side, I want those parts to be listed in that order. So I want an angle, and then a side. So it tells me I'm going to need angle F. Okay, same thing over here. I need an angle, and then a side. So that piece of information that I need to add, that I would need to know, would be that angle F is congruent to angle L. Then I do have my angle-angle side scenario. Okay, and number 2, we want to change this. We want to use the side angle side scenario. So I know I need 2 sets of sides with an included angle. So let's go ahead and mark what was given to us on this diagram and try to test that out. So FH is located here and side LN. Those are congruent. Then we have angle H here with angle N. Now, what would I need to prove the triangle's congruent by side angle side? Well, we'd want to be in that order: side, then the angle, then the side. So to make that work, I want to be at the side, the angle, and then the side. Okay, that angle has to be in between those 2 sides. Okay, same thing over here: side, angle, side. So this tells me I needed side GH, okay, and side MN, okay, as that third congruency statement, so that I could make those 2 triangles congruent. All right, now without actually writing the proof out, can we just determine what postulate or theorem we would use? Okay, here's the given. Again, angle V, which is right here, is congruent to YXZ, which locates right here. So I've got 1 set of angles. Okay, then I list a set of sides. Okay, XW, which is right here, and YZ, right there. Okay, that's only 2 pieces of information. You always need at least 3 to fit one of our cases. So now when I see this part here, that XW runs parallel to YZ. Well, parallel lines are going to create a set of congruent angles somewhere. So I need to see, and you might want to just kind of expand or trace over this. You can really see where a transversal here, okay, would be located between these 2 parallel lines. And I notice that I've got corresponding angles in these 2 locations. Okay, upper right-hand corner, upper right-hand corner. Okay, so I've got corresponding angles that are congruent because of my parallel lines. So then I've got angle, let's see, VXW, which was congruent to angle XYZ. So now I have 2 sets of angles and a side. Well, I've got 2 choices. I've got angle, side, angle, or angle, angle, side. So I have to look at the order in which it's marked on my diagram. And I should see I've got an angle, and then a side. Angle, angle, and then a side. So I would be using that scenario, okay, to write this proof out. So that would be my case for congruency. Okay, let's try 2 more of these. Here where we need to kind of just state that postulate or theorem. Now, keep in mind, mark your given information, but then make sure to look at what you can determine from that. Okay, so in this case, we're given that side SP is congruent to TP. Then we are told that PQ bisects angle SPT. Well, if it bisects, it divides it exactly in half or into 2 congruent parts. It's going to divide it into 2 congruent angles. And then the third thing I should notice is that we have a shared side. So that side would be equal to itself by a reflexive property. And I can tell I've got a side, then an angle, then a side. So this would be my angle side angle case. Okay, and then this last one, same thing again. AE congruent to CE, so AE and CE. Then AB congruent with CB. And then we're told that E is the midpoint. Well, if E is a midpoint divides the segment into two congruent parts. So then here we have, excuse me, we have three sets of congruent sides, and side, side, side is one of those congruency cases. So we could prove that these triangles are congruent. All right, we're going to stop here with this lesson, okay, a little bit shorter. We just wanted to add in our new case and really kind of analyze what case are we really using for congruency. And then start thinking about the reasons, okay, that you would be placing if you have a written out proof, because this next video is going to really focus in on writing the proofs themselves.